Hi, welcome to Bits and Proofs. Today we are going to draw clean lines between three terms that get used as if they are the same thing. Generative AI, Agentic AI, and AI agents. They are related, but they are not interchangeable. By the end of this video, you will have a permanent mental map. Let's start with the short definitions. Three terms, three different things. Generative AI is a class of models that produces new content like text, images, audio, and code. The defining property is generation. It outputs something that did not exist before. An AI agent is a program that decides and acts in a loop. It perceives its environment, decides what to do, uses tools, observes the result, and repeats until a goal is reached. Agentic AI is an adjective. It describes AI systems that show agent-like behavior, such as making decisions, taking actions, working toward a goal. It is a property, not a specific product. The reason these get confused is that marketing pages swap them mid-sentence. Today we draw clean lines. Now look at the hierarchy. AI is the broadest term. Inside AI sits machine learning. Inside machine learning sits generative AI. And inside generative AI sit large language models, the specific kind that produces text. AI agents live on top of LLMs. They are built using a language model as the brain plus a loop and a set of tools around it. So agents are not a child of generative AI in the classical sense. They are a software pattern built on top of it. What does generative AI actually mean? A generative model learns the distribution of some kind of data and then samples new examples from it. It produces, that is the only requirement. It shows up in 5 common families. Let's look at each one. First, text, large language models like GPT, Claude, Gemini, and Llama. Given a prompt, they generate written language. Second, image diffusion models like Stable Diffusion, Midjourney, and Dolly. From a text description, they generate a picture. Third, audio, speech, and music synthesis like 11 Labs, Suno, and Music Gen. They generate voices and songs. Fourth, video, diffusion transformer hybrids like Sora, Veo, and Runway. They generate moving images from a prompt. And fifth, code. Code-tuned language models like Codex, Claude, and DeepSeek Coder. They generate working source code. Notice the key point. Generative AI produces output. It does not, on its own, take action in the world. A diffusion model rendering an image does not also send the image somewhere. That is where agents come in. And although it feels new, the idea of generative models is decades old. What changed in the last few years is scale and quality. LLMs are the specific kind of generative AI that produces text. A large language model predicts the next token in a sequence. Given everything written so far, it predicts what word comes next. That is the entire API, conceptually. You give it a prompt, the capital of France is, and it returns the next token, Paris. One token at a time, conditioned on everything before. And that is the entire mechanism. Everything else, like instruction following, reasoning, and conversation, emerges from training on enough text and predicting the next token well enough. There is no separate reasoning module. This is important to internalize. An LLM is generative AI. It is not an agent. By itself, it does nothing until you call it, and it forgets everything when the call ends. The model has no loop, no memory across calls, no ability to act. To turn an LLM into an agent, you have to add the loop, the memory, and the tools yourself. That is what the rest of this video is about. So what makes something an AI agent? An AI agent is a program that runs in a loop. It perceives the state of the world, decides what to do next, acts on the world, observes the result, and repeats until a goal is reached. The LLM is usually the brain of the loop. It is the part that decides, but the agent is everything around it. The loop itself, the tools it can use, the memory it carries between steps, and the check for when the goal is done. Without the loop, you have a generative model. Without the tools, you have a chatbot. Put all three together, the model, the loop, and the tools, and that is what people mean by an AI agent. The agency is not a binary. There is a spectrum from purely passive to fully autonomous. At one end, a plain chatbot. It answers questions from training data, no tools, no actions. Next, a tool using assistant. It can call functions, but one step at a time with you in control. Next, a multi-step agent. It chains tool calls toward a goal, but still under human supervision. And at the far end, an autonomous agent. It sets its own sub-goals and runs unattended. So the further right you go on this scale, the more useful the system can be, and the more careful you have to be about what it can do. Autonomy and risk grow together. Now let's separate AI agent from agentic AI. These two phrases are not interchangeable. A agent is a noun. It refers to a specific program. You can point at it, cursor's coding agent, a LangGraph workflow, an OpenAI assistance run. Each one is a single identifiable agent. Agentic AI is an adjective. It describes how a system behaves. Agentic workflows, agentic capabilities. Agentic systems, every AI agent exhibits agentic behavior. But not everything described as agentic is a single discrete agent. Sometimes it is a pipeline, a workflow, or a feature inside a larger product. There are four nearby words people use, often interchangeably, that actually mean different things. A chatbot answers questions in a single domain, like a customer support FAQ bot. No side effects. An assistant gives general help and can sometimes use tools. That is plain ChatGPT or Claude. A copilot works side by side with you inside a tool like GitHub Copilot or Cursor Inline. It suggests you accept. An agent is goal-directed and takes multi-step actions, sometimes autonomously. Cursor's agent mode, or Claude Code, are the canonical examples. The boundary between assistant and agent is fuzzy and moving. The same underlying model can serve both roles depending on the UI that wraps it. Now let's see where these terms overlap. The diagram has three regions. Some systems are generative only, a diffusion model rendering an image from a prompt. No loop, no decisions, no tools. It just produces output and stops. Some systems are both generative and agentic, like Claude Code and Cursor's agent mode. Picture an LLM, which is generative, sitting inside a loop that uses tools, which is agentic. This is where most of what people call an AI agent lives. And some systems are agentic but not generative. A classic robotics planner or a reinforcement learning trading bot. It acts in a loop. It does not generate text or images. The key point: generative AI and agentic AI are independent properties. A system can have either, both, or neither. One more concept: multi-agent systems, several agents, each with a specialized role, exchanging messages to solve a problem together. A typical example from coding is a code review pipeline. A planner breaks the task into subtasks. A researcher reads the code base and gathers facts. A critic checks the planner's output for gaps. And an executor edits files, runs tests, and reports back. Each one is a small focused agent. Together, they do work that no single agent could do as well. The mainstream frameworks for this are LangGraph, Crew AI, and AutoGen. The cross-vendor protocol for agents from different companies to talk to each other is called A2A, which stands for agent to agent. Multi-agent systems are powerful but expensive because every agent is its own LLM call. They are most useful when subtasks really are independent and benefit from a specialist. Let's look at the mechanism that makes any AI agentic. Tool use: this is the bridge between the generative model and the world. Here is how it works. The LLM does not run code or call APIs by itself. It requests a tool call in its output. Your program runs the actual tool. Then you feed the result back into the model and it continues. A simple example. The user asks how many open issues in our repo. The model emits a tool use token saying call github.list_issues with state equals open must copy no. Your code runs the call, gets back a list of issue IDs, feeds it back to the model. The model then formats a natural reply. You have 7 open issues. The vocabulary for this varies by vendor. MCP standardizes it across providers. OpenAI calls it function calling. Anthropic calls it tool use. Same idea, 3 names. And this is the key idea. Without tool use, an LLM is a generative model. With tool use, a loop around it becomes an agent. The mechanism is small. The implications are large. Let me leave you with a 4-question decision tree. Next time someone uses one of these words, just ask in order. Question 1, does it produce new content like text, image, audio, or code? If yes, it is using generative AI. Question 2, does it run in a loop, taking observations, deciding, and acting? If yes, it is an AI agent or a multi-agent system. Question 3, does the term describe a system or workflow that shows agent-like behavior? If yes, the adjective agentic fits. And question 4, is ChatGPT an AI agent? The answer depends. Plain chat? No, it is just an assistant. With tools, web search, or agent mode enabled, yes, it is acting as an agent. 3 independent tests. Memorize the questions, not the buzzwords. Thanks for watching. If this helped you, hit subscribe. More AI engineering content is coming soon. And while you are here, check out the other AI engineering videos already on the channel. See you in the next one.